Hi, this is Tyler recording for 2007 part B, number 4. This is basically a question of a graph of f prime x. Please notice that it's f prime instead of f, so that the point f prime of 0 would mean it has a relative maximum or minimum or critical point depending on the situation. And this is always derivatives graph, not the actual graph. So you have to actually think about the graph as an integral of this graph. By the way, part A is asking me to find value x which f has a relative maximum, meaning whenever they ask me about relative maximum or minimum, I get to think about a x squared graph that has minimum, and when you flip it over, you're gonna have like mountain which is negative x squared, and that has a relative maximum at x equals 0, right? Because when you plug 0 in, the excuse me about this unbearable pen that doesn't really work. Okay, hopefully it works. Okay, it works. Alright, part A, you're gonna have maximum that looks like this, which has derivative of negative approaching 0 to positive. So at that x equals 0 for fx equals negative x squared, you're gonna have relative maximum at x equals 0. That's how I think of. And in this case, it's from negative to positive, always from negative to positive. This area is negative, this area is positive. That is from negative to positive right here. You have a maximum. Is that true? No, not true. It's from positive to negative. What am I doing here? From positive to negative at x equals 4. That's one case. From positive to negative at x equals 3. Negative 3. This is tricky part because it looks like f prime x is like infinite right here, the vertical line, but this is, please note that this is f prime's graph, not fx's graph, and those two are most likely to be the only points that are maximum, relative maximum. You don't have to think about the endpoint because at endpoint it's not crossing over the border, so it's not actually having a maximum, because in order to have a maximum you need right or left, both points on the left limit and right limit, but you don't have both in this case. Plus the range is not inclusive, it's exclusive for -5 and 5, so you cannot really think about those endpoints, which is cool. It makes the problem easier for students. For part B, you have to find all values of x at which the graph of f has a point of inflection. So f is one integral above, so which is one more dimension from this graph. I don't even want to draw it. It depends on constant always. I don't even want to think about it, but we already know that f second derivative would be first derivative of this graph because there's no c involved anymore, and that should have changed, it's hard to say, from negative to positive value, which means it has to be 0 at a certain point by theory of mean, I think. And then f double prime of x equals 0 occurs when the graph fits the horizontal line right here, and doubly at, excuse me, let me quickly move this a little above. Wait, why can't I do that? Oh my gosh. Alright, so I'm moving the whole picture downward, which doesn't work. Okay, so right here at 2.2, you're gonna have some really cool stuff, because look at this. You have a sharp edge right at 2.2, and that represents change of f double prime x, because it's kind of from positive some value to negative some value if this is graph of f prime prime x. And I'd call it inflection point because the derivative is changing from positive to negative or from negative to positive. But this is you definitely have to care about it when you say it in the AP problem. And try to control Z so that we have a nice little space we used to have before. Okay, good. And part C asks me to find, so the answers would be -4, around -1. I'm estimating it using my eyes, and a 2. All intervals on which the graph f is concave up, which is from -3 inclusive to +1 inclusive. However, you have to read it to the end. Also has positive slope, which is only starting at -1, which is inflection point. So the x would be inclusive -1 to 1, but at 1, think about it, it's f prime x equals 0, so I would not want to include that point. Okay, so from -to 1, it's that easy. I don't think I have to write any reasoning, but I would definitely write what I just said in actual AP. For D, find an absolute minimum value of fx over the closed interval. So this wants me to evaluate the endpoint. Please compare the range set up by the AP Central for D and B and A. For B and A, you don't even have to think about -5 and 5 because you don't have an equal sign. But the only change is for interval is that you have an equal sign. That's a lot. That's tremendous amount of work that has just been added. Okay, but we have to do it because we're doing the test. Excuse me. So for -5, we already know that where the relative minimum occurs, right? That occurs at when the graph comes from the derivative becomes positive from negative, and at that 0 point you're gonna have relative minimum, which could be absolute or not. That's why you have to now consider the endpoints. Okay. So I think -5 would be minimum as long as when you add those areas up. So when you integrate the whole thing, if you can get positive value, or the other choice would be, I think, at 1, because from 1 to 4, think about it, you're only adding the area, but when you're not adding the area, you're subtracting that much area. If you think backwards, if you're moving from 4 to 1, so actually you don't even want to think about that. You only want to think about those points from -5 to 1. I'd prefer adding them up. Just look, but the reality is, just look at the size of the circle. You're gonna have smaller value at negative. You're gonna have smaller value at x equals 1 than x equals -3. That's x equals -5 because you're adding just a little bit of portion between -5 and -3, but you're actually subtracting a huge, much bigger portion from -3 to 1. So I'd say x equals -1 has absolute minimum. Please note that when you integrate functions like f squared plus x plus 1, you are getting plus c at the end when you integrate it over for the respect of x, and those really matter. But in terms of doing indefinite interval from like a to b, you don't really want to think about it, because you already know the c, kind of know the c, and you hold it from -5 to 1. You don't even have to consider when you are subtracting one point from the other. Right, thanks for watching. This was Tylee.